Hello students, today we'll discuss about different types of forces. So till now what we have discussed is that is called as force. Now we'll discuss about its different types. Now broadly if you'll see, the forces are divided into two main categories. One is called as contact force and second one is called as action at a distance force. Or we can say that is a non-contact force. So in the previous class you might have learned it. So you learned about different kinds of forces, like if you see the different examples like muscular force, frictional force, gravitational force, electrostatic force, magnetostatic force. So there are so many different kinds of forces we come across in our day-to-day life. Okay, so here basically we divided all these forces basically into two categories. One is called as your contact force and other one is called as your action at a distance force, or which we called as what, non-contact force. Now let's discuss about contact force. Now what is the definition for this contact force? So that means if force is applied on a body by the actual physical contact then this is called as contact force. So that means what? When you are applying this contact force, there is a physical contact is must. Then only you can apply. Now under this case, if you see there are so many examples will come here. Like one of the example is frictional force. Frictional force. This is one example of this contact force. Now what is frictional force? Now whenever a body slides upon the other body, let's suppose this is a body which is sliding, okay, which is sliding upon the other body. So whenever it is sliding, so there is an opposing force comes into play, and that opposing force is called as what? That is called as a frictional force. So that means if the body is moving in this direction or sliding, so this is the direction of slide, so sliding in this direction, then the frictional force will just act in the reverse direction. Now you can see here, so this frictional force always act in between the two surfaces in contact. So where it is acting? Here. So where the two surfaces are in touch or in contact, so there actually exists the frictional force between them. Okay, so that's the frictional force is applied so by the physical contact of the two bodies. So that's it. This is called as what? A contact force. Similarly, if we'll go for another example for this frictional living this frictional force. So one more example if we'll consider. Now the second example under this is called as your normal force. Normal force is another example of a contact force. What is normal force? Like suppose this is the tabletop and on this, let's suppose there is a box is there. So this is a table, right? And on it there is a box is lying. Now when this box is lying, its weight is always falling on the table. So that means the box is applying the force on the table. Okay, so its weight is acting in this direction. But you might have noticed that due to this weight, the box is not going what? Downward. But the table is as it is there, and the box is also balanced on the surface of the table. It's not going down. So why does it happen here? Because the weight which is acting in the downward direction, it is counterbalanced by another force. Who is applying this force? The table is giving a force to the box, and this perpendicular force which is given by this table to the box, this is called as your normal force. So this is the normal reaction force. So this is the normal force. Here you can see this normal force where it is acting when the two bodies are in contact. So that's it. This normal force which is acting between the two bodies, it is also an example of what? Contact force. So like that, so many examples are there which you can notice in your day-to-day life, where you can see that when the two bodies are in contact, there only this force come into picture, and that force is called as what? Contact force. Now we'll discuss about the second kind of force, which is called as non-contact, or you can say action at a distance force. So this is action at a distance force. So since I said it is a non-contact force, or that is action at a distance, that means what? The force is applied on a body without any physical contact. So if there will be no physical contact between the two bodies, but still the force can be applied, then this type of force is called as your action at a distance force, or this is called as what? That is a non-contact force, right? Now here under this, there are so many examples will come. Like one of the example is your gravitational force. Gravitational force. What is this gravitational force? So this is a force which is existing between any two bodies in this universe. Okay. So you can say gravitational force is a kind of attractive force. That means suppose this is a body and this is another body B. So two bodies we have considered, or two objects we have considered, object A, object B. So there is always a force of attraction between them. So that means here you can say A is attracting B towards it, and simultaneously B is also attracting A towards it. But here you can see both the bodies are at distance, but still there is a force of attraction is there. Okay, so this force of attraction which is existing between these two bodies, though they are not in physical contact, this force is called as what? Gravitational force. That's why this gravitational force is coming under what? That is action at a distance force. And due to this gravitational force, that's why whenever we leave a body at certain height, from certain height, what happens here? Always the body goes down due to this gravitational force, or you can say the gravity. The force of gravity pulls that body towards the earth. So that's why what happens whenever body falls, so always goes down. So this is an example of what? Action at a distance force. Similarly, another example if I am taking for this action at a distance force, that is your electrostatic force. Electrostatic force. So this electrostatic force means actually this is the force of attraction or repulsion between two charges. Okay, so when we are taking two charged particles, let's suppose this is one charge. So charge is denoted by the sign small q. So here let's suppose this is a charge q1, there is another charge q2 is there. So here always there will be a force of attraction or repulsion existing between them depending upon the nature of the charge. So the charges may be positive, charges may be negative. So if I am taking one positive and other one is a negative charge, so always there will be a force of attraction. That means both will attract each other. But so that's why this is called as what? Unlike charges, both opposite charges, which is called as your unlike charges. So unlike charges, what? They attract each other. But if I am taking two like charges, suppose both positive charges, Q2 is also positive. So both the positive charges, what happens here? There will be a what? Repulsive force will exist. So this is called as when we are taking two same charges, either two positive charges or two negative charges. So these are called as like charges. So these are like charges. So two like charges always repel each other. So that means both tries to move away from each other. So here you can see that though these two charges are not kept together, they are not in physical contact, still we can feel the force of attraction or repulsion. So here the best example is, so you might have heard it or you might have seen it, experienced it. I can say you have experienced it. Like if you take a comb, that is plastic comb, and you pass the comb through your dry hair for some time. So what happens here? The comb gets charged. Now after that, this charged comb, when you are showing to the small bits of paper, you will see that the small bits of paper will get attracted towards it. Okay, so why this that papers are getting attracted? Because of this electrostatic force. So that means when you are taking a comb like this, so this is the comb, okay, so this is the comb, and here I am taking small bits of paper. So once the comb is getting charged by passing this comb through the dry hair, it is getting charged, okay, so this is a comb here. So when it is getting charged, so when I am showing it to the that bits of paper, so here due to induction opposite charges are getting developed. Suppose this comb is getting positively charged, this is getting positively charged. When I show to the bits of paper, the bit of paper due to induction, what will happen? They will develop opposite charges, negative charges will they get developed. And due to that, since this is positive and this is negative, and what I said here, one positive and one negative, this is called what? Unlike charges. And what the unlike charges they do? They show the force of attraction. So that's why this papers, small bits of paper which are actually the charged ones, so they are getting attracted by the comb. So this is actually coming under electrostatic force. And here we can see, though this paper and the comb, they are not in touch with each other. They are not having any physical contact, but still there is a force of attraction we can see. So this is a kind of called as what? Action at a distance force. Okay. So here I think you must be clear about what is a contact force, what is a non-contact force, or you can say action at a distance force with their examples. Okay. So that's all for this video. So next we'll see something else in the next video.